Okay, so far in this chapter we've been dealing a lot with variation equations, and all the variation equations we've been using have all been in terms of just one variable. Well, in the real world that's not always the case. Like, just think about area for a second. A lot of formulas for area involve two variables. For example, area of a rectangle would be base times height. Well, so you could say the area of a rectangle is directly proportional to the base and the height. So we're going to be looking at some examples today, or actually one giant example. It's going to be a continuing example, looking at a scenario in which we're trying to figure out a formula for the maximum weight that a board can handle. As you can see from this diagram, there's going to be three variables involved. We could be both the thickness of the board, the width of the board, and the distance between the supports are all going to affect how much weight the board can handle. Now, in order to be able to accomplish this, if we were actually to do this as an experiment, we cannot have more than one variable being adjusted at a time. In other words, what we're going to have to do, or what the book's going to do for us, is we're going to have one situation where maybe we look to see how the width affects how much weight the board can handle. And if we do that, the distance between the supports, that's going to have to remain the same, and the thickness of the board is going to have to stay the same. So the only thing that's changing is the width of the board. And we do a bunch of experiments, figure out how much the board can handle, and then we move on to a different variable like the thickness of the board. And if I was testing the thickness of a board to see how it could affect how much weight it can handle, I would keep the width of the board constant, meaning I would just use the same width for all those experiments, and the distance between the supports would also remain the same. So let's just jump right in here. Don't worry too much about all that. I think a lot of that is repetition of what we've been doing in the previous lessons. So I think it makes more sense just to jump right into an example here. So in this situation, what they're doing is they're looking at the width of the board and how that affects the maximum weight that the board can handle. So to do this, they're using boards that are all the same, where the supports are going to be all 12 feet. The distance between the supports are all going to be 12 feet long. And the thickness of the board is going to be 1.5 inches thick for each of these. So in this table, what they've done is they've done this experiment where they said, okay, if we have a board that's 1 inch wide, that's 1.5 inches thick, it can hold 9 pounds. If it was 2 inches wide and 1.5 inches thick, it could hold up to 18 pounds, and so on. So what we're trying to do is, the example kind of gives it away, but we're trying to figure out how does the maximum weight, or how does the width of the board affect the maximum weight. The first thing you need to look for is an example of direct or inverse variation. You can clearly see that as the width of the board increases, the maximum weight the board can hold also increases, telling us that this is an example of direct variation. So I need to figure out then, is this an example of it being in the general form, y equals k times x to the first power, or y equals k times x squared. Now we don't use x and y in this situation. We're using w and m, so I'll make that adjustment here in a minute. But as we look at this, let's just pick a number like 2 and 6, for example. 2 times 3 gives me 6, so now I need to see, well, would 18 times 3, would it be 18 times 3 squared? That would give me 53. Well, 18 times 3 gives me 54. 18 times 9 would give me 162. So, knowing that, again, since 18 times 3 gives me 54, it doesn't give me exactly 53, that reminds me that this is just a model. This is going to give me close to the answers that I have here for my maximum weight, but it's not always going to give me the exact answers, but it should be really close for all of these. So again, my exponent is just going to be a 1, or just not going to be any exponent at all as far as what we're going to see. So I want to write this in terms of m and w. So instead of saying y equals k times x, for this one it would be m equals k times w. Now if they ask us if they don't in this situation, but if they did ask us to find a variation equation, what that means is that they want you to find a specific equation for the scenario. So in which case you get to pick any pair of numbers here. Let's just keep it simple for right now. Let's just use 1 and 9, meaning I'm going to put 9 in for M, put 1 in for W to figure out what K is. Obviously in this case, K would equal 9. Telling me that my specific equation, if they ask us for that, would be M equals 9 times W. But I want to go back to this. What this means then, what we just found, is that the maximum weight that the board can hold is directly proportional to the width of the board. That's how we would phrase it. Now you want to remember that, because we're going to come back to this at the very end. Because our goal again is to come up with one formula that's going to combine all of these general equations into one. Let's go to the next part. So now we already looked at the width of the board, now we're going to look at the thickness of the board. In which case, we're going to again keep the distance between the supports the same at 12 feet. We're going to keep the width the same at 2 inches. So all of these boards are 2 inches wide. We're just varying the thickness of the board and measuring how much weight they could handle. So you can see a 1-inch thick board could hold 8 pounds. A 2-inch thick board could hold 32 pounds, and so on, all the way up to a 6-inch thick board could hold 288 pounds. Again, your first step for these is to see, is it an example of direct variation or inverse variation? So since they both increase, we know it's an example of direct variation, so it's in the form of y equals k times x, or y equals k times x squared. I just got to figure out which one. Just like we did before, we can use any pair of numbers here. Let's change it up a little bit each time. Let's do 2 and 4 this time. Okay, well, 2 times 2 gives me 4, so I want to figure out, well, is it going to be 32 times 2 or 2 squared? That would give me 128. Should be pretty obvious, but let's go through this. 32 times 2 is 64, not 128. 32 times 2 squared, or 32 times 4, is exactly 128. So that tells me that my exponent is going to be squared. So now, as far as putting it in terms of the situation we're looking at, again, this is my x, this is my y, so I'm not going to say y equals k times x squared. I'm going to say m equals k times, t squared. So now they ask us to find a variation equation in this one. So we're going to pick a pair of numbers here. It can be any pair of numbers. Let's try 5 and 200 this time. So I'm going to put 200 in for m. Put 5 in for t. And when I do that, I'm going to divide both sides by 5 squared, or 25. 200 divided by 25 gives me a value of k, which would be equal to 8. So now my specific equation would be m equals 8 times t squared. And I forgot to do this in the previous one, but you should always go back and check and make sure that the specific equation, or the variation equation that we found, really does work to give us the numbers in the table. Now you don't want to test it with the number that we picked, okay? Because what if we made a mistake? You want to make sure that you try numbers that are not the pair that you picked. So for example, if I put 1 in there for t, well, 1 squared is 1 times 8, sure enough, gives me 8. So that checks. If I put 2 in there for t, 2 squared is 4 times 8 is 32, that checks. 3 squared is 9 times 8 is 72, that checks. So you can see that it's working for these numbers, so I know that our variation equation that we came up with is a good model for this situation. But now again, let's go back and look at the general form we came up with. So what we found is that the maximum weight a board can handle is directly proportional to the square of the thickness of the board. Okay, again, remember, we're going to come back to all those in a minute, so just make sure that we remember that. Okay, the only thing that we haven't dealt with is the distance between the supports. So now what we're going to do is we're going to keep the thickness the same. We're going to go back to using a 1.5 inch thick boards, and we're still going to use boards that are 2 inches wide, and we're going to use varying distances between supports to see how the distance between the supports affects how much weight the board can handle. So you can look at the table. They did that for us. So a 1 foot distance between supports can hold 212 pounds. All the way up to 6 feet between the supports can hold 35 pounds. So as you look at this is an example of inverse variation. As the distance is increasing, the maximum weight the board can hold is decreasing. So this is in the form y equals k divided by x. Or k divided by x squared. Now remember with these, this is all going back to lesson 2.3, that fundamental theorem of variation. That's what we're doing at this point. Remember, whatever happens to x, the opposite happens to y to the nth power. So let's say if I use 1 and 4 in this case. So whatever happens to x, the opposite's going to happen to y. So for this particular problem, I want to see, well, is it 212 divided by 4, or is it 212 divided by 4 squared? That would give me 53. Well, if you try this out, 212 divided by 4 gives us exactly 53, telling me that it's not going to have an exponent. It's just going to be, or it has an exponent of 1, so it's just going to be in the form y equals k divided by x. Putting that into the context of this problem, we would say that m equals k divided by d. So if we want to come up with a specific variation equation, they ask us to find the constant of variation k. In order to verify the relationship between m and d, we need to have a specific equation so we can try it out. That's what they're asking us to do. So let's use a different pair of numbers here. Let's use 2 and 106. So if I put 106 in for m, I'm going to put 2 in for d. So when I do that, multiply both sides by 2, I get k equals 212. And by the way, I'm just using numbers that are not 1 and 212 just because sometimes in your homework assignment they don't always give us the pleasure of having one where your independent variable would be a 1. But obviously if it does, that would be the easiest one to use, so you could always use that one. Okay, so now we know that k is 212. So now I know my specific equation is going to be m equals 212 divided by d. So if they ask us for the variation equation, this is the one that we would use. But as far as how these two are related, we would say the maximum weight a board can hold is inversely proportional to the distance between supports. So now let's put this all together. So if we were to summarize our findings, what we would do is we would say that, remember we had m equals k times w, we had m equals k times t squared, and we just found m equals k divided by d. So to summarize this, we would say that m varies directly as w and t squared, and m varies inversely as d. So basically what we're doing is we're combining each of these situations all into one sentence. Now we don't have to separate the direct variation. We can combine those. We can say m varies directly as w and t squared. And then we just write a separate part there to say that m varies inversely as d. Now that's how we would summarize it. If you're asked to create a single formula, we combine all of them together as one. Now if it's already there, you don't have to repeat it. So we would say m equals k times w times t squared, all divided by d. Again, since we have 3 m's there, we only need one of them. Since we have 3 k's here, we only need to have one of them. But it would be k times w and t squared, so that would go in the numerator. And all of that would be divided by d since it's inversely proportional to d. Now watch the next video, and I'm going to go over some of the problems that you'll see in your homework assignment.